In less than a decade, a nuclear reactor could be humming on the surface of the moon, powering our return. NASA says it's essential for humanity's future among the stars. But some experts warn this ambitious plan could ignite a new, more dangerous kind of space race. Who will control the power of the moon, and at what cost? In a bold move signaling a new chapter in space exploration, NASA has set its sights on building a 100-kilowatt fission reactor on the moon by the early 2030s. This ambitious project isn't just a technical milestone, it's the essential foundation for establishing a permanent human presence beyond Earth, providing the lifeblood for everything from breathable air to future industry. But the moon is an incredibly harsh environment. The lunar night lasts for 14 Earth days, plunging any outpost into a deep, freezing darkness. Abrasive lunar dust can coat solar panels, drastically reducing their efficiency. And some of the most scientifically valuable locations, like the permanently shadowed craters at the poles, never see sunlight at all. Solar power alone simply can't guarantee the continuous, robust energy required for a sustained presence. This is precisely why nuclear fission has emerged as the leading solution. A compact reactor can deliver a steady, reliable stream of energy, completely independent of sunlight. We're talking about a system capable of generating power continuously for a decade or more, operating through the long lunar night and even in the perpetual darkness of polar craters. It's a game changer, a technology that fundamentally redefines what's possible for building a lasting outpost. The first lunar reactor will be far more than just a power source. It will be a beacon of human ingenuity. In an era of renewed global competition for celestial dominance, it represents the foundational infrastructure that will transform the moon from a place we visit into a place we live, paving the way for humanity's future as a multiplanetary species. The era of planting flags and leaving footprints is over. As nations and private companies set their sights on a permanent, sustained return to the moon, the stakes have never been higher. This isn't just about exploration, it's about occupation, industry, and long-term survival. At the heart of this new era is the challenge of building and protecting critical infrastructure, like nuclear reactors, on a world with no borders. To address this, NASA proposes safety zones around vital assets. On the surface, these are practical necessities designed to shield sensitive equipment from abrasive lunar dust and the seismic shockwaves from nearby landers. But these zones also raise profound questions about access and control. In this crowded new frontier, a simple safety measure can look a lot like a territorial claim, a potential flashpoint in a brewing global competition. The new lunar race is on, and it's a crowded field. The United States, leading the Artemis program, is in direct competition with the rival China-Russia collaboration on the International Lunar Research Station. They are joined by ambitious nations and private companies, all vying for a foothold on the most valuable real estate off-world, the lunar South Pole. Its crater rims offer near-constant sunlight, while the shadowed floors hold frozen water, the key to life support and rocket fuel. The 1967 Outer Space Treaty forbids any nation from claiming sovereignty, but it's a relic of a different era, silent on resource extraction. So while safety zones are presented as a cooperative measure, they could easily become de facto territory. Who gets to draw the lines? Who enforces the boundaries? The answers will define the new balance of power. For every player, one truth is clear. Power is everything. Electrical power. The lunar night lasts for 14 Earth days, with temperatures plunging to minus 170 degrees Celsius. Solar panels go dark and survival depends on massive batteries that can't support large-scale operations. This is where nuclear fission becomes the game changer. A compact reactor can provide a constant, reliable stream of energy, day and night, enabling industrial-scale mining, 3D printing habitats, and fueling a true off-world economy. The first to master this technology won't just be powering their own outpost. They'll be in a position to set the technical standards, control the energy market, and dictate the rules for everyone else. The moon is the first great arena of interplanetary strategic competition. But this opportunity comes with unprecedented risk. A catastrophic failure during launch could disperse radioactive material into Earth's atmosphere. On the lunar surface, the perils multiply. Operating a reactor in a vacuum, with extreme temperature swings and the threat of micrometeoroid strikes, is a monumental challenge. A single accident could have irreversible consequences. On the moon, with no atmosphere, radioactive particles would settle into the soil and stay there, essentially forever. A spill could contaminate the very water ice that is the primary reason for being there. poisoning the well for all future generations and destroying priceless scientific records preserved for billions of years. So the ultimate question is not simply who will get there first, but how we will behave once we arrive. Who will write the rulebook for this new frontier, and who will be held accountable when things go wrong. The decisions being made today in boardrooms and government offices will have consequences that last for millennia. Will the moon become a model for peaceful scientific cooperation? Or will it be the next battlefield for old terrestrial rivalries, exported to the heavens? It is our ultimate proving ground, a test not just of our technology, but of our collective wisdom. And the world is watching. Imagine a moon transformed, not just a desolate destination but a thriving outpost of human ingenuity, powered by the steady hum of nuclear fission. This isn't science fiction, it's the blueprint for our future. With this energy we can build sprawling laboratories shielded beneath the lunar regolith. Here, geologists will unlock the moon's 4.5 billion-year-old secrets, while astrophysicists build unprecedented telescopes, free from Earth's distorting atmosphere. In vast subterranean greenhouses, LED suns will nurture crops, providing not just sustenance but a vital psychological link to home. The lunar surface will become a crucible of innovation. The blue marble of Earth hanging silent in the black sky will be a constant reminder of what we're working to protect and how much farther we have yet to go. The economic potential is staggering. Habitats and tools will be 3D printed from local materials, reducing our reliance on costly launches. Manufacturing in a vacuum could produce flawless fiber optics and perfect metal alloys, impossible to create on Earth. But the ultimate prize might be helium-3, a rare isotope in the lunar soil. It's a potential fuel for clean, safe nuclear fusion, a technology that could solve our planet's energy crisis. The moon could become the powerhouse not just for our off-world ambitions but for Earth itself. This abundance of energy unlocks the moon's most critical treasure, water ice, hidden in the permanently shadowed craters of the poles. Robotic rovers will mine this frozen resource, melting it for processing plants. There, electrolysis will split it into its core components, breathable oxygen for life support, and liquid hydrogen and oxygen, powerful rocket propellant. The moon will transform into a cosmic crossroads, a bustling refueling station. Spacecraft destined for Mars and beyond will no longer need to fight their way out of Earth's deep gravity well with full tanks. They can launch light, refuel at the moon, and then embark on the next great leap. It is a vital step in making humanity a true spacefaring civilization. But we will not be alone. As nations and private pioneers flock to this new frontier, the moon becomes a complex canvas of human ambition. On one side there is unprecedented collaboration. The Artemis Accords, led by the United States, champion a shared vision of peaceful, transparent exploration where international teams work side by side. Yet a rival vision is also taking shape, with nations like China and Russia forging their own path. This competition can be a powerful engine for innovation, pushing technology forward at a breathtaking pace, but it also carries the risk of conflict, of turning the lunar landscape into a new arena for old-world rivalries. The question of who owns the moon's resources and who sets the rules has never been more urgent. The stakes are immense, but the rewards could redefine our world. The technologies developed for the moon, advanced robotics, closed-loop life support, and efficient nuclear power, will have profound applications back on Earth. This lunar endeavor is also our ultimate insurance policy. By establishing a self-sustaining presence on another world, we ensure the long-term survival of our species, safeguarding consciousness from any single planetary catastrophe. This is where the first real steps toward an interplanetary civilization are taken. Living, working, and building a permanent society beyond our homeworld. The goal is not merely to survive on the moon, but to thrive there, creating a legacy that will echo across the solar system. And the countdown is already underway. On Earth, engineers are testing prototypes, refining designs for reactors that are small, safe, and powerful enough for the harsh lunar environment. Soon, the first of these will be loaded onto a lander. Its activation, the first controlled nuclear fission on another world, will be a moment as significant as the first fire harnessed by our ancestors. That low, steady hum will break the eternal silence, signaling the dawn of a new human era, one defined not by limitations but by boundless energy. The choice of what we do with that power is ours alone. Will we use it to build bridges or walls? To unite in exploration or to compete for dominance? The technology is nearly ready. The future awaits. The moon is calling to us once more. And this time, we are building the means to stay.